What is real? How do you define real?
You can't jump into cash. Cash is trash. What do? You get out.
Kalle Rosenbaum has worked as a software developer for 20 years. His passion for Bitcoin started in 2013 and has continued uninterrupted. Kalle started a Bitcoin consultancy company in 2015 and has worked in the space since. He also writes a blog that explains various technical topics on Bitcoin. He's also the author of Grokking Bitcoin, which explains why Bitcoin supporters trust it so deeply and why you can too. This approachable book will introduce you to Bitcoin's groundbreaking technology, the key to this world-changing system. You'll discover how Bitcoin mining works, how to accept Bitcoin, how to participate in the Bitcoin network, and how to set up a digital wallet. It's remarkably approachable for non-technically minded individuals and a great read on Bitcoin. Welcome to the Bitcoin Matrix podcast, Kalle. How are you?
Thank you very much. I'm fine. I'm glad to be on here.
Thank you.
At last. I know we had an appointment last week, but I failed. I'm sorry for that.
Yeah, no worries. Those things always seem to work out. And I actually feel even more prepared to talk to you now. I'm even more excited. It gave me a little more time to dig a little deeper. One thing I was trying to get my head around, what is kind of your programming background before 2013, before Bitcoin? I kind of have a little bit of an idea of kind of things you were interested in, but I don't really know what you were working on or your experiences.
Yeah, I mean, prior to Bitcoin, I was mainly a Java developer. I was writing Java code for various companies, product companies. I wrote boring software for project and project portfolio management and stuff like that. I started out with a small company called Focal Point, who built a requirements management software. And then eventually they got acquired by IBM. So I got into even more boring programming there. And after that, I left to start in the consultancy business. So I started working with as a consultant instead. And that turned out to be also very boring programming, working for various government agencies and stuff like that. So that wasn't very fun. So in 2015, I started my own Bitcoin consultancy. So that's where I am now.
Was any so it sounded like most of the things you were working on were closed source or proprietary corporate stuff. Yeah. Were you interested in anything open source before Bitcoin?
Absolutely. I was a huge open source advocate. I mean, I've been a Linux fan since forever and been running Linux since, well, I don't know. And always enjoyed the open source movement. I didn't participate in it very much because I had a day job. But I was looking for open source opportunities. And that's one thing that got me into the consultancy business after the IBM, because they had a profile on open source software like Red Hat Linux, for example, and JBoss, which is an enterprise application platform. And that got me drawn to that, but it turned out to be mostly closed source development I did there as well. So, but yeah, I always loved open source, and I love to see how open source software can make stuff better. It's just inevitable that it sooner or later will invent better stuff than the closed walled gardens can do.
Yeah. How did you learn programming?
In school, I guess. I studied computer science, and that's basically where I started.
Did you start with Java?
No. My first programming language was probably Fortran or Pascal. But that was just for education. I mean, so my first professional language was Java. And I stayed in Java for all the time, up until 5, 6, 7 years ago.
How different are the languages, or how easy it is to go from or migrate from one language to coding in another language?
It depends on what language. For example, if you didn't learn C++ as a kid or in school,
Right.
you'll probably find it very hard to do it.
Is that the hardest?
For me, it is, at
Yeah.
least. I find it very hard. And I mean, if you go from Java to C#, for example, I probably think that step wouldn't be that much of a difference because they build on the same concepts. They are both heavily typed and object-oriented languages. And then you have the group of functional programming languages. Scala is one of them, and Go. And so as long as you stay within that, your
Right.
paradigm, it's pretty easy to shift.
How did you come to Bitcoin then? You're coding, you're consulting now. It sounds like you're still, doing a lot of like computer science things in your free time, but I don't know exactly how you're dabbling with open source systems or how you come to Bitcoin.
Yeah, how I come to Bitcoin, I remember seeing on Twitter a guy that I knew was mentioning Bitcoin. That was probably 2012 or something like that. He wrote a plugin for some content management system to receive Bitcoin payments. But of course, I didn't pay much attention back then. It was a few months later that it popped up in my feed again. And I can't really remember. Maybe it was on a podcast actually there was a podcast called the Linux Action Show, which is a nerd show for Linux enthusiasts. And they mentioned Bitcoin, and they started a specific podcast for Linux or for Bitcoin. So I started listening to that. And that's probably what got me started. I think they were actually, they could have been the very first Bitcoin podcast out there. I'm not sure.
And maybe how long before, like from that moment to like looking at like the source code, did you ever, I'm assuming you looked at the code of Bitcoin. So about like, what was kind of the journey between like learning about Bitcoin to how long before you were kind of like ripping open the hood?
I haven't used the source code of Bitcoin Core that much in my learning path. I use it to look up specifics every now and then. And since I'm not a C++ programmer, I find it hard to actually browse the source, but I use it every now and then to just look up specifics. But I use BIPs a lot, Bitcoin Improvement Proposals. Those are like specification documents.
Well, I meant more in your rabbit hole story. Like what was the first time? Like, do you remember? Like maybe did you read the white paper early on?
Yeah, I did.
And did that maybe? I'm assuming you got a lot more out of it than I did, because there's certain sections where I kind of gloss over, and it's only 9 pages, and I still got a lot out of it, and it was kind of mind blowing. And I'm wondering, like, kind of, was it one of the first things you went to after learning about Bitcoin, or did it take a year or two to get to the white paper?
No, I tried to read the white paper quite early on, and but I wasn't in the field of cryptography. I wasn't in the field of distributed systems. I knew very little about that, and reading the white paper at first was a big challenge. So I had to combine that with all sorts of input, like Reddit and even YouTube videos explaining how Bitcoin works. And so I had to learn basically from scratch. Just because I was a programmer didn't make it much easier for me to grasp Bitcoin, because I didn't know about the concepts that much. So it was a pretty tough learning curve for me.
What were your impressions of it? And maybe use Linux as like a comparison, or any open source system. Were you thinking of it as maybe, I kind of thought about it early on as just, this is really cool. People could use this money to do their own thing. I never really thought about it as like a network that would grow in value. I never Napster never became something you could kind of get a piece of, that kind of thing. Like, so you're kind of learning about it. Like, when did the sort of the monetary aspect of it kind of come, or any, I don't know if I'm putting words in your mouth, but any other aspects besides programming and open source come into it for you?
Yeah. At first, I saw it as a cool payments network.
Right.
I guess that's probably what most people see at the first glance, a payments network for payments, and they probably dismiss it because this can never scale, right? But and I can't really remember the order of events.
Sure. Yeah.
But
I'm going more the feeling.
Yeah, at some point I started looking at more of the social aspects of it, how it enables people. I was listening to a lot to Andreas Antonopoulos, for example, and he talks a lot about banking the unbanked and all that. So that got to me pretty early, and then the monetary aspect of it came probably later. When I started seeing the power of hard money. Yeah.
Right. Did you pivot to consulting in Bitcoin before writing the book?
Yeah, I did. It was a year or two in that I was contacted by Manning, the publisher Manning.
Right.
And they asked me if I wanted to write a book.
Going back to going before the book, and you're going to become a Bitcoin consultant. You're going to form a Bitcoin consultancy. Was that sort of a huge leap of faith in yourself? But I'm thinking even more broader in Bitcoin, that you're kind of determining Bitcoin's going to be around to build a firm around.
Yeah, absolutely. I definitely knew that Bitcoin was going to be a part of my life, of course, but it was a big risk I took. I didn't know how to make money as a consultant in Bitcoin, because the Bitcoin scene in Sweden, at least, is not that big. There were a few firms, but eventually I started to know various people around, and eventually I was asked if I wanted to join Cefello, which is a Swedish exchange that I work with a lot.
When you were kind of making that pivot, I know it's hard to remember, but do you think it was more of like a pivot to more consulting and more open source work, or like a real hard pivot to Bitcoin?
I was hoping for more pivoting to more open source software. But the consultancy work I've done so far has been closed source.
Right.
So basically, paid work seems to be mostly a closed source.
Sure.
But yeah, so I'd love to contribute more open source, but to make a living, most of us probably need to do some closed source.
I was just wondering at that point how much faith you were putting in the Bitcoin network versus like almost just because a lot of it is going to be in yourself. I mean, you're going out on your own, and I'm thinking there's the moment there where you could be like, well, Bitcoin doesn't work out. I could do Linux, or I could do other open source or other consulting work, versus like, oh, I'm really pivoting all hardcore about Bitcoin. This is the future of my life, and maybe the monetary system.
Yeah, I didn't think in terms of a fallback solutions. I just went for Bitcoin. I thought that we'll see where it goes. And I mean, being a software developer, it's not a big risk to try something new. You can always go back to your old field if you fail. I mean, it's really not a big risk in that way.
So when Manning,
go ahead.
When Manning approached you, so you agreed to do the book. The book is amazing. I think it's actually, the subject is incredibly intimidating, and the size of the book makes it feel intimidating. But you open up the book, and it's not intimidating at all. And the way you lay it out, it's very clear. I think it's very simple. But I'm wondering, like, so what were your goals with writing the book, and is the book what, you set out to do, or is it very different, and better in different ways maybe? Or
It's quite different, actually. When I set out to write the book, I was aiming to make it less technical, and to be more. I wanted it to be back then. I wanted it to be more shallow, and use more analogies and that type of explanations.
Right.
But as I wrote, I realized that I can't write like this. I need to go deeper. That's just how I am. I couldn't leave a dangling thread. So it turned out to be a really deep dive into the technicalities of Bitcoin.
I think it's one of the deepest dives I've read, because you really build it from the inside out. And it really makes me, and I always wondered about this a lot, but this book in particular made me dwell on it. It's just, I wonder how Satoshi went about this project, and whether Satoshi built it from what I would view as the inside out, where you just start coding and you just code away, and then you run into problems and you solve. So you build to constraints, versus more like maybe whiteboarding it and kind of blocking or categorizing what you need to build, and then building kernels and molding together. So more outside in. I wonder if you have a perception on that.
I would guess that things happens in parallel. I mean, he probably start whiteboard. Maybe he whiteboards a bit, and then he codes a bit, or they. That's just how general development usually works. You just hack away and see where it goes, and just run into problems, as you say. I think that's how it happened. But he probably had a general idea, but you can't really iron things out without trying it, actually coding it, because that's when you hit the corner cases.
Right.
Yeah.
And how has the reaction been to the book?
It's been tremendous. Everyone who reads it seems to enjoy it very much, and they seem to learn a lot from it. And I'm just really glad for all people who reach out to me and tell me what they think about the book. So I think it has like 5 stars on Amazon right now. I'm not sure. So the reception has been very good. It hasn't sold very good. I don't know the numbers, but a few thousand copies maybe.
Right.
3,000 copies. I don't know.
Well, it's also open source. You provided open source. It's interesting on Twitter. I see your book pop up a lot. And it's interesting. I wonder how many, people are using the book to learn how about Bitcoin, to code. And I wonder what their interaction with you is like, if they DM you questions, or kind of like get in touch with you as they're going through the book.
Yeah, mostly they just reach out with specific questions if they didn't grasp a paragraph, or if they think they have found an error or so. So there are some errors in it, God knows. But yeah, so it's mostly about specific questions about this and that they didn't grasp, or they want me to elaborate on.
Do you think it's non-technical people trying to grok it, or do you think it's technical people trying to understand the system even better from like maybe a non-programming perspective, but like kind of like the conceptual basis behind the code?
Yeah, so if you're not technically interested, you're going to have a really hard time reading this book, because it is very technical. That said, you don't have to be a programmer to understand these concepts. And I try to teach the concepts of Bitcoin on a conceptual level. So anyone with a technical interest should be able to read this book. And when it gets really hairy, I usually warn in the book. I put up a warning in the book saying, hey, this section here is going to be really hairy. So if you don't want to read it, just jump to section blah blah blah. But I think most technically oriented people should be able to grasp Bitcoin from reading this book and grasp it on a pretty deep level. The book doesn't use any code. We use only, it's just illustrations and concrete examples, and we try to build maybe I should mention how the learning path of the book is organized. So we start out in chapter 2 with a very simple spreadsheet system that keeps track of money. That's centrally controlled by a central authority named Lisa. And she keeps track of this spreadsheet.
Cookie spreadsheet.
Who owns what, yes. And we call them cookie tokens. We use another term than Bitcoin, not to confuse people of what's actually Bitcoin and what's this imaginary system.
Right.
And then we add technology to this centralized system, chapter by chapter, adding technologies until we end up with Bitcoin in chapter 8. So in chapter 2, we add cryptographic hash functions and digital signatures. And chapter 3 adds Bitcoin addresses or cookie token addresses, and so forth until we end up in chapter 8 with where we add the final piece of the puzzle, which is the peer-to-peer network. And then we have built Bitcoin, and from there on we talk only about Bitcoin. So I think it's a good way to get into Bitcoin, to actually not learn about the full Bitcoin system directly, but start from a stupid system and make it better.
Right.
That gives you a better idea on what components or what technology is used for what problems they solve.
And the choices
every chapter starts out with kind of defining a problem that we need to solve, and then we solve it with Bitcoin technology.
Yeah, I mean, I thought it really fit like a person like myself, who I would consider sort of technically minded but non-technical. So I like looking at technical things and discussing them and learning about them, but I'm not looking to learn the language of C++ or to code it myself. This was really interesting too, because you see those choices of like a closed system being built into an open system, sort of like an evolution there, or it's never really a closed system, but like kind of like a controlled system, or how a system kind of evolves and is emergent and then becomes more decentralized. The one thing I did find probably intimidating were the exercises. I find it very hard in my free time to bring myself to do exercises of my own volition. Another thing though, when I read a book, any Bitcoin book, but I always wonder how they're going to kind of fit into the academic canon of Bitcoin literature as we progress. And this is a book that I see very much fitting, and I don't say this in a lowly way, I say this in a very highly way, like in the academic world, in kind of instructional. I can see this as very advanced high school for computer science and programmers, and to learn about systems. And then definitely in the college and university arena to kind of like parallel with programming. Because I like how it's not coding, but you learn how to build the system. Another thing that was really fantastic about the book was definitely the foreword by David Harding. We DM'd a little bit back and forth about that. I wasn't as familiar with his history in Bitcoin and his contributions, but what an eloquent foreword. I just want to touch on, ask you what it was like to have him write that for your book.
Yeah, so it's I'm really honored that he wanted to take the time to do this, and I too love his foreword. So I've seen him for a long time on social media or in code reviews and all around the place. He just writes excellently wherever he writes, whatever he writes. He's a great writer and a great explainer. So I was very, inspired by him. and he agreed to write this forward. So yeah, and I like especially one section towards the end of his foreword. If you don't mind, I'll read a little section.
Sure.
Can I do that?
Sure, that'd be great.
So he writes like this: Bitcoin needs books like Grokking Bitcoin, but it also needs an active group of users who read those books and come to understand the technical principles on which Bitcoin is built. During these early days of what I hope will be the long history of Bitcoin, users are often asked to evaluate proposed changes to the system, changes that may affect the security and privacy of their Bitcoins. Those who have read this book will understand how the system prevents cheating and will be able to help ensure that future changes preserve that essential feature and its many benefits. So I think he circles this very well. He pinpoints it very well, that Bitcoin security, Bitcoin's fundamental properties relies on a user base that needs to understand these principles in order to preserve them. And by reading a technical book like this, you will become more part of that system or of that defense.
Yeah. Yeah, I thought it was a very powerful forward. The notes, I am really glad you picked that paragraph. And just to touch on it a little bit more, the notes I wrote down were kind of like how Bitcoin effectively prevents cheating without requiring the banning of any user. And that's incredibly timing and in this moment in time. No one can cheat effectively, and your book really walks you through that, how the system can't be cheated by anyone, no matter, and there's no, it's safe to allow everyone to participate in every part of the system, and no one holds a trusted position of authority. And one that's very interesting is that there's no need for identities. Can you maybe touch on that a little bit in Bitcoin? How there's no, maybe how there's some non-currency uses?
Yeah, there are some non-currency uses, but there are quite few, if you ask me. Most non-currency uses turn out to be more or less bloat on the Bitcoin blockchain. And once fees start to rise, those use cases might not be so viable anymore. So long term, I don't see a lot of non-monetary uses. But one use case is, of course, timestamping. You have this open timestamp system that you can build a huge tree of, or rather, to put it simply, you can prove that a document existed prior to a certain time in the Bitcoin blockchain. So you can make a cryptographic hash function, a cryptographic hash of a document, and you store that hash in the Bitcoin blockchain. And when you later want to prove that this document existed prior to that, when you store the hash in the blockchain, it will be stored in a block, and that block will have a timestamp on it. So later, when you want to prove that this document existed prior to that timestamp, you show the document and you show the hash in the blockchain. So you show the blockchain, okay, here is the hash in the blockchain, and here's the document that hashes to that specific hash. So you can prove that this document must have existed prior to this block. And that can be useful for various stuff.
I think that's going to be tremendously useful and powerful technology going forward. I can't think of what the use case is right now for someone like myself. I have a feeling it's, just in document and proof and governmental things, I think it'll be very important, and maybe even around news and sort of social items, proving when and if things happen. I don't know how it's going to look and how that will play out, and whether that will be on the base layer or not, or how much will be on the base layer.
Yeah.
How long did it take you to write the book?
Sensitive topic. No, it took me 2.5 years.
Wow.
Actually, it took me 1.5 years to write the content, and I mean to get a draft ready. And then we worked together with Manning to do typesetting and illustrations. I did the original illustrations, but we had professionals from Manning actually doing the nice looking ones that you see in the book.
They're beautiful.
Yeah, they are. I love them very much.
So it must have been amazing to see it come to life that way, like a movie almost.
Yeah, actually, it was a struggle.
I'm sure.
At first,
tremendous amount of patience.
At first, we didn't have a very great illustrator, so we had him exchanged for another one. So that was a bit painful. But,
yeah,
but once we got this new illustrator, it was very nice to work with him. He did a great job there. So it took us 1 year of illustrations, typesettings, proofreading, and all that. And that was a very frustrating period for me because it took a lot more time than I had anticipated. And it was a struggle actually, mentally.
Sure. Must have been a real relief when it finally came out.
Yeah, it was great.
So let's dive into the book a little bit. So, why do we need Bitcoin? What are some of the problems with money today?
The biggest problem I see right now is money printing. I mean, the euro supply, M1 supply, has increased by like 50% the last year, or more than 50%, and the US dollar has also increased more than 50% this year alone. So we're going to see some heavy inflation going on for price inflation going forward now. It will probably lag a bit. I'm not an expert on economic topics, but I can see a price inflation coming because the supply has increased so dramatically.
Yeah.
And I think Bitcoin will become more and more of a safe haven for asset managers. And also, I think the permissionlessness is like, it's just a no-brainer. Once, if you've been in Bitcoin for a long time, of course you see it as a natural thing, but I just think the barrier to entry to the status quo systems, banking, and is just enormous for especially poor people, and cross-border payments. And you have sanctions against Iran, for example. Iranian people can't trade internationally because their government fucks up. But so there are so many problems that are obvious that we need to fix. Sure. And Bitcoin is probably alleviating some of that, hopefully.
I probably don't ask this question enough. What is Bitcoin?
Bitcoin is the world's only digital pie. So think of it as I think of Bitcoin as a pie chart.
Right.
But it's the only digital pie we have. Everyone wants a piece of this pie, and that will have, of course, tremendous effect on the price. So, right. Yeah. So well, I see it as a digital pie.
Interesting. What is the Bitcoin approach then to some of these issues we have with money today?
Sorry?
What is the Bitcoin approach, to some of the problems we have with money today? How does Bitcoin approach them differently?
Yeah, it's the permissionlessness and identitylessness, if you will. You just the problem with inflation is fixed with a fixed money supply, and the problem with barriers to entry is fixed with identitylessness. Yeah, I don't have any good answer, better answers than that, I think. Yeah.
So let's get more into the technical stuff. What do nodes do? What's a node and what do they do? And
yeah, a full node will verify every aspect of the Bitcoin network for you. If you don't run a full node, let's start with if you want to use Bitcoin, if you use a so-called web wallet, you log into a website with a username and password, and this web wallet will show you your balance and it will show you your financial information. You have to trust that web page. You have to trust the website with both your financial information, that is correct, and you also have to trust them not to steal your money. So when you use an online web wallet on a website, they can take your money and they can lie about everything to you. And then another way to use Bitcoin is to use something called a lightweight wallet. A lightweight wallet is like also called, sometimes called an SPV wallet. And those are a little bit better because there you have custody of your own private keys that are needed to spend your Bitcoins. So no one else can spend the Bitcoin as long as you keep your private keys safe. No one else can take your Bitcoins. But those lightweight wallets actually rely on information from other third parties on the internet, like various servers on the internet, to get information about transactions. So yes, with my lightweight wallet, I know that my funds are safe, but I can't, you can lie to me about an incoming transaction. If you have a web server that my wallet uses to get information from, your server can lie to my wallet and say, hey, here's an incoming transaction. And I can't really verify that, whether that is true or false. So with a lightweight wallet, your funds are safe, but your information is not safe. The information you get from that wallet is not safe. And then we come to the next level, is a full node. So with a full node, you have custody of your own keys, and you also verify all the data in the Bitcoin network. So you don't have to trust anyone else with providing you this data. And by doing a full node does that by downloading all the blocks, the full blockchain from other peers on the Bitcoin network. They download the blocks, they verify, the full node will verify every block and every transaction in every block, and make sure that every rule in the Bitcoin system is followed. And because this full node has all information, it downloads the full blockchain. So it has the full information of all transactions ever made. And when I want information about my wallet, if I want to query, look how much money is on this address, for example, I can query my own full node for that information. So that query doesn't go out to some third party. That information stays on my full node, and I don't have to reveal what addresses I have to anyone else. For example, so with a lightweight wallet, when you ask third-party servers for balances on an address, for example, you will reveal to them what addresses you have, and if you make several queries to the same server, they will be able to see, oh, this address and this address belongs to the same wallet because it came from the same IP number, so they can make that heuristic, connect those two addresses together, and that happens a lot. There are a lot of Electrum servers, for example, that are the backend servers for the Electrum wallet. And those are operated by Chainalysis and companies like that to actually cluster addresses together. So that's not good for privacy. So running your own full node is actually a great privacy enhancer as well, because you don't have to reveal to other third parties what addresses you have.
Right.
So to summarize, a full node will keep custody of your own keys, so you don't have to rely on anyone else to keep your keys safe, and it will provide you with the correct verified information that you know is correct. You don't have to trust someone else with that, and you don't have to reveal your financial information to others. So that's
okay. So that was great. But how does my node then communicate with other nodes to get information from the broader network when needed?
Yeah, so the broader network is what you call a peer-to-peer network. And when someone finds a block, for example, a miner mines a block, and they want to publish that to all the other nodes, it will just pass it to, the miner will be connected to several nodes, not all nodes on the network, but several nodes, and send this block to all its peers. And those peers will send the block, verify the block, and send it on to their peers, and so on until everybody has it, or at least most of them have it. So that's how data is propagated in the Bitcoin network. It's called a gossip network, and that's pretty much explains it, I think.
Right.
So yeah. The network is just flooded with information like that.
You mentioned rules and miners. So what are the incentives for miners to follow the rules?
Yeah, so if a miner wants to get the block rewards, which consists of both newly created Bitcoins, but also of transaction fees. So the block reward is new coins and transaction fees. And in order to get that reward, the block has to be valid. So if a miner tries to cheat, tries to create more coins for himself than the rules than the rules allow, this block will not be valid, because there's a fixed schedule for coin issuance. And if a block creates more coins than allowed, nobody will accept that block. When he sends this block to his peers, the peers will just know this block is invalid. It creates too many coins. I'll just drop it and throw it away. And then he has spent a lot of electricity to create this block. I mean, he needs to create a valid proof of work to start with. So in order to create a valid proof of work, he needs to spend a lot of electricity. And if he then creates an invalid block and spends a lot of electricity on that block, he will throw his money. He will just throw that. It's just wasted electricity, because nobody will accept that block.
Right.
And that's the importance of full nodes, because only full nodes can actually verify blocks.
Right. Well, what is the mempool?
The mempool is, as I said before, you have blocks propagating the network, as I mentioned, in this gossip network. And when I create a transaction and send it out on the Bitcoin network, it will propagate in the same way as blocks do. It will be sent to a bunch of nodes, and those nodes will send the transaction on to their peers and so on until everybody has it. And when a node receives a transaction, it will be added to its mempool. So there's not the mempool. There are lots of mempool. Every node has its own mempool. It's just a memory area that the program uses to store transactions that hasn't been confirmed yet, waiting for confirmations. So, and then when a miner mines a block, let's say I am a node, I have put your transaction in my mempool. You have sent out a transaction on the peer-to-peer network, and my node receives that transaction and puts it in the mempool because it's not part of the blockchain yet. But I need to remember this transaction for future stuff. So I just keep it there in the mempool, in this memory area. And everybody else does the same. And when a miner mines a block with this transaction in it, let's say you pay a fee high enough so that the miner is willing to take it into his block and create a valid proof of work for it. And the miner publishes this block on the same peer-to-peer network, and this block will propagate the Bitcoin network, and eventually it will reach my node. And when I see this block, I can verify the proof of work of the block and every aspect of this block. And I also see that this block contains the same transaction that I have in my mempool. And I have already verified that this transaction is valid. So I don't have to verify this transaction again. So this makes block verification faster, because I can verify the individual transactions before they appear in the block. So when the block comes to me, I can verify most of the transactions very fast because I have already verified the signatures and everything in those transactions. And when I accept the block as valid, I add it to my blockchain and delete the transaction from the mempool. So it's just a temporary storage area for verified transactions.
Yeah, that was awesome. Very illuminating. I'm trying to, I think one of my favorite subjects to learn about this year is going to be cryptography. So, and your book kind of helps lay that out. So what is a cryptographic hash, and how does a hash function work?
Okay. First of all, big disclaimer, I'm not a cryptographer. Sure. I mean, what I wrote in this book is basically everything I know about cryptography and a little more than that. So yeah, but a cryptographic hash function is one of the key concepts in Bitcoin. It's one of the most fundamental concepts.
It's the root.
Yeah.
It's the root.
Yeah. If you get only cryptographic hash functions, you can get very far in Bitcoin.
I think this is the least grokked point or root in Bitcoin. When it comes to things like even just with altcoins, and the mutability of real cryptographic work.
Maybe. So let's say I want to send a cat picture to you through email, and let's just start with explaining what a cryptographic hash function is. A cryptographic hash function is a function. It has one input and it has one output. You can view it as a computer program, a little computer program that has one input and it has one output. The input can be anything. It can be the string hello. It can be my complete music library, or it can be the law book, or anything, or a Bitcoin transaction for that matter, or a Bitcoin block. So that is the input of the function of this computer program, and then you have the output, what comes out in the other end when you run this program with this music library as input. On the other end comes a 32-byte 32 bytes of data, a huge number, if you will. You can view it as a huge number. So it's a 256 bits of data. So that's 32 bytes. And that data will look like a random sequence of bits, like 11000010111110. So it will look random to an observer. And if you take the same music library every time as input, if you take the same music library again and use it as input to this program, you will get the exact same random looking number. It's not random, but it's random looking. And one important property here of this function is that the output is a fixed length. It's 32 bytes for SHA-256. There are several different variants of this, but this SHA-256 specifically is 32 bytes output. And every time I input the same music library, I will get the same 32 bytes. And if I change one song in this music library, I have 1 million songs in the library, and I change one song. I just change the file name of one song or something like that. A little bit. I just flip a bit somewhere in the input, and I run it through this function again, and out comes a totally different value than I had before. So this new random looking number will have no similarity with the previous one. So I change just a little bit of the input, and the output is completely different. And you can't really anticipate what that would be. So that's a really important property. A slight change in the input will create a huge change in the output.
Right, completely, it'll look completely randomized.
Yes, it will.
And there's no way to back into it without just brute force.
Right. Yeah. So you can't look at the 32 bytes and say, okay, let me run this function backwards and get my music library back. No, you can't do that. First of all, it's obvious because you can't create the whole music library from only 32 bytes. Right? But even if the input is 32 bytes, you can't reverse this function. It's a one-way function, and that's a really important property. And that's used a lot in Bitcoin. For example, that is how blocks refer to each other. So one block will refer to its predecessor, the previous block, by its hash. So in the block, a block has a block header, and in this block header is a pointer to the previous block, and this pointer is the hash of that block. So that's how you identify blocks. A block ID is actually the hash of that block. More or less, yes.
Do you think cryptography is a weapon of war, or some form of defensive weapon of war?
Yeah, I would say so. We are becoming increasingly aware of Big Brother, and the only way to keep our privacy is the use of cryptographic tools, and it's
How many?
I would just say yes to your question.
Fair enough. It was interesting when I was in grad school. I don't know why this came up, but we would study this program, this cryptography, where you could take a picture, like say from Disney World, and embed another picture in it, and encrypt it in a way that no one on the outside could tell the difference between the two pictures. But so it would appear that the key would come out the same on the other side, even though they were altered.
I think it's called stenography, isn't it?
I'm not sure. I don't remember. And I just remember at the time thinking this was a really big deal.
You encode stuff into something.
And then it doesn't look different to outside parties. And this was like around terrorism and communications. And I don't know why we were going over that or how that plays into how I'm learning about cryptography with Bitcoin. But one of the questions I wanted to ask was, how many hashes can a desktop computer run? Like, I don't know if it's per second or per minute or whatever the metric is.
I think I calculated it once.
I'm not going to hold you to the
it's
number,
like-
but
It's like 100 million per second, maybe.
right. And yet still that's not like, I guess, enough power to kind of brute force your way into these answers.
No,
Yeah, I mean, it is enough
absolutely not.
power, but over a long period of time.
Yeah. You need like the age of the known universe.
Right.
That amount of time in order to do it with a laptop.
Right. And if you had more power, then you got to consider how much power you're spending to then consume or obtain whatever you're trying to acquire.
Yeah. If you look at the whole Bitcoin network as a whole, produces, is it approaching 1,000 exabytes? I'm not sure, but I think it's somewhere there.
Yeah, I don't know if my mind can comprehend those kind of things.
And those 1,000 exabytes they can only, even they can't brute force a single hash. But they can find, what they are trying to do is find close hashes that almost matches the hash you're looking. So let's go back to the music library. If you have an output and you want to find an input that matches that output, you want to find an input to cryptographic hash function.
The answer
that produces this
certain output.
That's called a pre-image. You want a pre-image to this output. And Bitcoin, when in proof of work, you try to find a pre-image that matches the current target close enough.
Right.
It has to be lower than the target. So you actually try to brute force this target with repeated hashing.
Yep. To win the lottery.
Yeah. So and it takes the network those 1,000 exahashes per second, 10 minutes to find one.
On average, right.
Yeah.
When you went over the different kind of different cryptographic, like kind of SHA-256 and different functions, and you mentioned something around like on SHA-1, a collision has been found. What does that mean? A collision has been found, and ramifications.
That means that someone, I think it was some researchers at Google, they managed to find two different inputs that produces the same SHA-1 output. So
it's a flaw in the cryptographic function that was built, and it wasn't perfected. Is that kind of, and so that kind of like makes it kind of not usable, I would think.
Yes.
For what we're, but at some point, I think what that infers to me is that some people thought that this was working, and then a flaw was discovered after continuous use or experimentation or research. People
kind of knew that there was a flaw, I think. I don't know the details of this, only that the researchers found
proved it right.
They had
so interesting.
A hunch on how to go about doing it, and they
did
it. They used a lot of resources to do it, but they did it, and that's proof enough. I mean, the proof that they found one is very simple. They provide two different inputs, and anyone can verify it. So, and that's proof enough to steer away from that.
I would think that's final proof. I would think, but I don't know enough about it. Jumping ahead in the book a bit, what is the difference between like kind of a soft fork and a hard fork?
Yeah. Okay. Can we just go back to
definitely.
There's a nice little thing that happened there with the SHA-1 issue, because Peter Todd, a developer, applied cryptography guy, everybody knows him. He actually put up a bounty on the Bitcoin blockchain. He put up a Bitcoin output that anyone who could provide two different documents for that.
Two inputs to result in the same output.
Yes, of SHA-1.
Right.
So when Google found these two documents, they could actually collect that bounty. on the Bitcoin blockchain. The bounty was for, I don't know, maybe,
But this was on, but the
maybe
bounty was on 256, SHA-256.
No,
Oh,
there is one. There is one on SHA. He put up several bounties, but one on SHA-1 and one on SHA-256, and I don't know. Maybe there's one for RIPE MD-162, but the one on SHA-1 was collected at that point by someone very quickly.
Right, but the one on 256 is still open.
Yes.
Oh, and he still has it up, like meaning like this might happen.
Yeah, I mean, he can't remove it. It's there.
Right.
Nobody can claim it.
Until it's claimed. So it's open permanently until it's claimed. So open doesn't mean that it's currently in a suspect per se, but it is open. So it could be claimed and one day it could be struck.
Yes.
Got it.
If someone finds a collision in SHA-256, they can collect that bounty. And it's a fun little...
I wonder how many people are working on that. And I wonder how many people were working on the SHA-1 and are still avidly working on, say, SHA-256, thinking there's hope. Bringing into question the validity of the encryption.
Yeah, I don't know.
Yeah, no, I have no idea either. I'm assuming it's very little, but it only takes one.
I mean, I think it's a pretty big research field, actually.
Okay.
Yeah. So
I was
a lot of
when I said little, I was
with hash functions. So
yeah, I was just inferring maybe the bright. It would take some of the brightest minds to do this, and so there's not a lot of people who might even have the brain power to step up to the plate. I'm not
maybe
sure.
that, or just being highly organized people. Maybe you need to be very
like task and
prudent.
plan oriented, right? I see what you're saying. So I guess jumping back to hard and soft forks, I mean, I think you kind of really shedded some or illuminated that really well, especially around like kind of backwards and forwards compatibility.
Yeah. So yeah, this is a pretty hard topic, but Bitcoin upgrades, if you want to make changes to the rules of Bitcoin, for example, if you want to make changes to how, let's say, the issuance rate of Bitcoin, the new Bitcoins in every block. Right now, it's 6.25 Bitcoins in every block. And in a few years, it will be halved into 3.1, whatever that is.
Right.
Yeah.
125.
Yeah. That's a predetermined schedule. It's part of the Bitcoin rules, and every node checks these rules. And if you want to change that, let's say that I want to change this rule. I want to increase this number, and let's say I create a block, and so I create a new piece of software. I change Bitcoin Core software a little bit. I increase the numbers to 7 instead of 6.25, and I want everyone to use my software because we want to make more money as miners, for example. And I give this software to you, and I convince you, hey, this is much better. I mean, we get more money out of this now, and maybe you're a miner too. And we start using this together. Then we are creating what's called a hard fork, which means that these blocks will not work on older nodes because we are breaking the rules of older nodes. And if we are breaking the rules of older nodes, we will not be part of the older nodes blockchains because they will throw our blocks away. So that is a hard fork when old nodes no longer work with this data, with this new data, with the data from new nodes. So this is not forward compatible, where data.
That's so funny. I think of that as backwards compatible.
Yeah, there's a.
And I get really confused. I get confused there.
Yeah.
And I don't think it really matters in terms of, I mean, it's just labels, but I would call that backwards compatibility, or that's not backwards compatible in my mind.
If you read the article on Wikipedia on backwards and forward compatibility, they say that if new software works with data from old software. So if you upgrade Microsoft Word to the latest and greatest, you can still open your old documents. That's backwards compatibility.
Mm-hmm. I get what you're saying.
Yeah, but if you open the latest and greatest version of Microsoft Word and you write your document there and save it, and then you try to open it with your old version of Microsoft Word, if that old version can read that document, it's forward compatible. I think it's
that's a good way of.
It sounds backwards,
right?
No
but,
pun intended, but yeah.
Yeah, no, I get it. It's a little counterintuitive, but it works when you break it down into a simple example like that.
Yeah. So, but nevertheless, if you make a rule-breaking change like this, increase the number of coins issuance, it won't work with old nodes, and that's a hard fork. And let's say instead, if we want to do another change to the Bitcoin Core system, we, for example, want to decrease the block size. We say, okay, now the maximum block size must be no bigger than 500K. Mm-hmm. The old nodes have the rule that they must not be bigger than 1 meg.
Right.
So we have the block size. The block size is halved according to our new rules. And let's say that you and I start using this software, and I create a block of 400K. So that's valid according to our new rules. And I send it to you, and I send it to another guy who's running the old node, or an old node. It's also valid according to his node because it's less than 1 megabyte. So that means that this old guy can open the Word document that's created with the latest and greatest Microsoft Word. It can open my block that's created with a new software. An old node can read data from a new node. That's a soft fork. That's a forward compatible change. So that's the difference with a soft fork and a hard fork. With a soft fork, old nodes will not be able to read the data or use the data. Sorry, with a hard fork, old nodes will not be able to read the data. With a soft fork, old nodes will be able to read the data. Did I say that right?
I think so.
Let me say it again.
Okay, sure.
With a hard fork, old nodes will not be able to read the data.
Right.
With a soft fork, old nodes will be able to read the data.
Right,
so
the chain continues.
Difference.
Yeah, no, that's great. What's going on in Bitcoin today that you're excited about from a technical perspective, if anything? I mean,
it's definitely Taproot. That's coming.
Yeah, and what got you excited? What's exciting about Taproot for you?
Taproot, for me, it's mostly exciting because it's a technically the cool thing.
Yeah,
but it also brings a lot of benefits, of course.
Yeah,
it will bring benefits to privacy, and it will bring benefits to block space and to verification efficiency. So it's a new address format, if you will. It's SegWit version 1. And it will bring, I don't know if we should go into detail, but it's the next version of SegWit that will, do stuff better, more efficiently. For example, you have the new Schnorr signature system, which will replace the old digital signatures with something called Schnorr signatures. And Schnorr signatures are cool because you can batch verify them. You can verify multiple signatures more efficiently than verifying them one at a time. So you can do it in a batch in a more efficient way. And also with Taproot, you can make several we already have something called multisig, which is multiple keys need to sign a transaction. That's a typical multisig. You need 2 of 3 signatures, for example. And in old SegWit or current SegWit, that appears as 2 separate signatures in the blockchain, which takes up like something like 2 times 70 or 72 bytes. So it's like 150 bytes, maybe, because you need to store 2 signatures in the blockchain, in the spending transaction. With Schnorr and Taproot, that very multisig will look exactly as a single sig transaction. So it would not be distinguishable from other transactions, like one single sig transactions or Lightning transactions, for example. I mean, Lightning opens and closes. So more transactions will look more similar on the Bitcoin network, which makes it harder for blockchain analysis companies to draw conclusions on what kind of transaction this is. So it brings benefits to privacy and a lot of other stuff. And also you can make more complex stuff in Taproot without revealing that full complexity. You can have several different spending conditions. I mean, you can. I can say something like, this output, this coin, will be spendable either by Cedric in 1 year. After 1 year, Cedric can spend it, or after 2 years, I can spend it, or if we agree, we can spend it together right now. And as a fourth option, anyone can spend it after 5 years, for example. But I don't have to reveal all those branches, all those options.
Right.
I only have to reveal the option I actually use. So that hides a lot of information about your
transaction.
Yeah.
Yeah. When you think about, you mentioned in the back of the book, the economic majority and sort of how, decision making within Bitcoin and kind of how to discern that and who should kind of have the rights to, kind of move the upgrades along or technological advances. And that made me think, though, broader, when are Bitcoiners going to be the economic majority in the global economic system?
Probably going to take a while. I won't go in there.
Okay.
I give it 20 years.
Are you going to write another book?
There's none in the pipeline right now. No. It was pretty exhausting. Sorry. So right now there's nothing ongoing.
Yeah. Well, the book
Maybe
is wonderful.
In the future.
Do you have any thoughts on? Would you like to share any thoughts on where Bitcoin might be in 10 or 20 years, or how it might affect the world on a greater scale over a long period of time?
Whatever I say is going to be wrong.
I know what you mean.
But I hope that. I just hope that people won't get punished too harshly for using Bitcoin by their governments. I think it might be bloody. I hope for a very slow adoption, because I think that will be less violent. But it's super hard to predict, but I'm afraid that some states at least will turn very violent on Bitcoin and punish people harshly for it, and scaring people out of their Bitcoins, doing everything they can to destroy Bitcoin and to make it unusable. And I think that's in the maybe that's 10 years from now, maybe we'll see some of that. But hopefully it will be slow and less violent.
Yeah, I feel like you have a deep reservoir of thoughts on a lot of these subjects, and I feel like maybe you stick a lot to the programming and the coding, and I hope over time, you share a lot more on that if it's right for you to do so. I feel like there's just so much that you're, just not holding back, but, there's a lot of reservation about getting into that. And I could appreciate that. I think there's some levity to that. And, my final question for you, just around what Satoshi did is, do you think what Satoshi did is kind of like, a great human achievement that is beyond remarkable to pull off? Or do you think it's a testament to human desire, persistence, and will to do what you set out to do, and you just got some code done? Is it beyond the pale, or is it, someone who just set out to get a job done and did it?
Good question. I think they set out to get the job done because there were a lot of discussions on how to decentralize money before Bitcoin. There have been several experiments with various coins before Bitcoin, but they all failed because they had some central point of control. So it was like, I think it was on top of some people's minds to actually create something like this, create the decentralized money. And they have been trying since the 90s, I think, to do it. And so probably there were multiple people trying to get this done. And eventually one of them just flipped the right switches in their minds and got it, standing on the shoulders of giants, of course.
Yeah. Do you think this was a marathon that maybe someone from the 80s and 90s completed, or more of a relay race that someone picked up the torch and was like, I get what you guys were trying to, get across the finish line?
I think the people who did it, who finally got it, I think Satoshi has been around for a long time. Maybe lurking in the cypherpunk mailing lists, or
Well, my final thoughts that I want to share are your words. So Bitcoin is designed for censorship resistance, and your quote: "We pay miners to perform correct, honest transaction confirmations. We don't pay them to decide the rules. We pay them to follow the rules. The rules are decided collectively by everyone, you and me, by running our Bitcoin software of choice." Kalle Rosenbaum. I think that what David said was right in the foreword. We need more people to understand Bitcoin and to be active users of the system, to protect the system and get where we want to go. So I really appreciate you taking the time to kind of walk me through some of these technical topics, and help me grok Bitcoin. This has been fantastic, Kalle. I just want to leave it to you if you have any parting words, and definitely let people know where they could find you and how to buy the book. I know they can go to Amazon. That's where I got it. Anything else you want to share?
Yeah, sure. You can reach out to me both on Twitter. I'm Kalle Rosenbaum there. KalleRosenbaum. Maybe you can put it on your show notes.
Definitely.
And on Mastodon, which is a decentralized version of Twitter, if you will, it's a decentralized microblogging platform system. I'm Kalle at bitcoinhackers.org on Mastodon. So please reach out there. There's a lot of people actually finding Mastodon and starting to use it, and it's a great way to avoid deplatforming.
I hear you. Thank you, man. This has been amazing. I really appreciate it.
Yeah, and if you want to get the book from Manning's website, you can use, I don't know, we won't use video in this, but I'll turn around and show you the back of my t-shirt here.
I'll screenshot that.
Yep.
Okay. Grokking Bitcoin 50% off at manning.com, Manning.com. Code TS Bitcoin.
Yeah, there you have it.
That's awesome.
Cool.
Thank you so much.
It was a real pleasure to talk to you. You made it really easy for me.
The pleasure was mine, Kalle. This has been great. Thank you so much.
Kalle Rosenbaum, author of Grokking Bitcoin, talking about cryptography, encryption, and the economic majority right here on the Bitcoin Matrix podcast. And thank you for listening. If you dig the chats, please subscribe and rate with 5 stars wherever you dome your pods. Those reviews are the best way to get the word out, so I can keep grinding out thought-provoking conversations on Bitcoin. And if you're interested in sponsoring the show or just want to shoot the shit, hit me up. My DMs are always open. This is Cedric. Peace.
What is real? How do you define real?
You can't jump into cash.